Yes, yes, yes. Screen is visible.
Okay, great.
So new module today.
So, yeah.
Okay, okay, cool, cool. Yep.
So, I guess you've gotten like idea on what's agent by now, right?
Yes, yes, yes.
So, yeah, just tell me like what's agent then.
Also, is it like agent as in like we create a particular kind of uh,
Mhm.
repeated if we have something some task which is repetitively used, so we
Okay.
create certain skills like
Mhm.
analyzing or simplifying or something like which is repetitive, like
Okay.
reading and finding a simplified version of that. So multiple set of skills will combined as a form of agent.
Okay. Maybe we'll take up an example. Okay.
Mhm,
So I'll give an example of like what LLM is, what it is. Maybe you can provide an example of like what AI agent would be. Okay.
mhm,
So we have LLM. Here comes like user request. Okay. The user request could be something like uh, maybe what happened on this day. Okay. Or on this particular day mentioned.
mhm.
Okay. May
Okay,
19th in
okay.
previous like in history. Okay. Something significant may have happened. So yeah, LLM is trained on this data, so it will respond back with something. It will respond back, right? So I get this data where it is saying like on 19th
Yes.
May. So these are the list of things that happened, right? So this is the usual LLM user interaction. So the generation is the main task of like LLM. Okay. So now agent. Yeah.
Hmm.
Maybe if you could frame an example, what an agent would be like. Yeah.
Agent can be, let's say, a developer, a software developer can be an agent like a Java developer,
Okay.
like who just code on Java language and
Hmm.
perform logic building and
Okay.
pushing the code to Git, and
Okay.
that's all. Kind of
Okay.
a agent.
So can I say a logic is involved here,
Yes, yes,
or
yes,
maybe yeah, we can also say a reasoning is involved here,
yes, yes, yes,
and there it includes some action.
yes.
Okay. So can I say like agent is something which can reason and take up action,
Yep.
right? So can I say this to be an agent?
Yes, yes, yes.
Okay, that's great. All right, we will recommend it. Okay. Yeah, we will keep it like this for now. We will go on with the flow and we will understand this better. So yeah, we have got an
Okay.
analogy to understand. So standard LLM, it takes text as an input. Okay, the input is text
Mm-hmm.
in the form of prompt. The processing is Blackbox LLM model, and the output is again text. Correct?
Yep.
Okay. So here this LLM is trained on this data, maybe some 18,000 to 2025. Let's just say. Okay, this LLM is trained on this data. Now,
Mm-hmm.
like if you ask something between this, yeah, it responds well. Even before 18,000, if you ask, yeah, it would hallucinate. And for 2025 onwards, yeah, it may hallucinate again, right? So
Okay.
there are no factual reasonings here. So we have a RAG concept, which is termed as to be librarian. So this basically the same model which was trained on like 1800 to 2025. The same model is being used and the input is
Mm-hmm.
still text, the output is still text, and
Mm-hmm.
but this has been attached with some external knowledge source. Okay, and this knowledge source could be anything.
Okay.
right? It could be data of 2026, or let's just say before 18,000, 1800, right? So this could be data of anything. Okay. So depending on this data, now the same model which was trained on like 1800 to 2025 data, now it can, using this data, it is trying to do some action, some operation that could be like it is basically summarizing this whole thing, external data. So whatever it is getting, right? So it is summarizing the thing, and depending on which it is responding, correct? So
Yep.
so
Yep.
here basically everything that's being done here, maybe fetching this, creating this external knowledge source, or fetching this external context. Okay, so this acts as a context, right? So this external context, fetching it to LLM, we are doing it, right? So the same input here, previously it was just user input. Here it is user input is being passed, plus we are internally managing with our Python. That is, we are arranging the context for this LLM to operate on. Correct?
Yep. Yep.
So now comes this agent, the worker agent. Let's just read this first. So we hand an LLM a set of tools, APIs. So these tools are nothing but APIs, and step back. The LLM decides if, when, and how to use these tools and solve the user problem. So again, here, if you could see, the input is still text, the output is still text. The LLM is
Yep.
processing, on the same data it has been trained on, but we
Mm-hmm.
are arranging it in external source. Okay, the Python is arranging it with using Python. We are providing the external source, so it is doing some operation with that data. So what agent is? So this is
Mm-hmm.
LLM again, but here instead of like us passing the tools, so it has got access to these particular tools. Okay, these tools could be API 1, API 2, API 3. So these APIs could be as simple as calculators. So LLM.
Mm-hmm.
So now by now we already know LLMs struggle with calculations, correct?
Mm-hmm.
Right. So internally it's a complex math it's doing, but yeah. But still, when we ask it as a prompt and it has to be generated, this calculations has to be done through generation, right? So it still struggles. Okay. So the external API, the tool could be as simple as a calculator. This could be calculator could be a tool. So now we are providing an API of this particular tool, maybe a function or an API. Okay. We provide this API as a tool to this LLM model. Now it will decide, it will, without our external help, it will decide when to use this tool and how to use this tool. Okay.
Mm-hmm.
Depending on, yes, of course, user query. Okay. Depending on the user
Okay.
query, it decides when to use or how to use that tool. Okay. But yeah, we provide with these tools. We can provide with set of tools. Okay. Not just one.
Okay.
Okay. Yeah. So element JSON. So again, let's not say LLM to be some now LLM has got access to these tools. Now it has got a superpower to access, and now it will act independently. So we will get Transformer 1, 2, 3 movie kind of scenes, right? It's not the way, right?
Mm-hmm.
So it has got access to these tools, but how to use these tools, we are guiding it. Okay,
Mm-hmm.
we have written our Python framework. Okay, which will guide these models on how to use these tools. Okay, so we may write up a JSON something like this. Okay, where we have defined tools, and within tools we have defined like which type of tool it is and what's the name of it. Okay, and what are the parameters to be used. Okay, so we are listing all these tools. So comma, there could be another tool. Okay, comma, there could be another tool. So we are passing this tool set. Okay,
Mm-hmm.
as a parameter to this LLM. That's why it is getting to know like these are the tools exist, and these this is the function name of that particular tool, and these are the operations that could be done using this tool. There may be a small description. Okay, and then the parameters which I can, like the arguments which I can provide
Mm-hmm.
to this particular function or this API in order for it
Okay.
to work, right? So that information we are guiding it. Okay, so when we say tools, LLM has access to tools and that becomes an agent. So it's not, that's for an analogy, that's good. But internally, that's not how it works. So yeah, it has got access to these tools, but we are the one who are providing these access. Okay, we are helping it out, we are guiding it out. So in order to
Mhm.
guide that, we are using JSON format. So LLM act as a reasoning engine. Yeah, we know that it can simulate intelligence, right? So it acts as our reasoning engine. We force it to output a structured JSON so our code can pass. So we specifically ask, like, let's just say it has to use a calculator. It wants to use a calculator tool. Okay. We force it to respond back with like we force it to present as an generated text where it says it wants to use a calculator. Okay. And these are the
Mhm.
parameters, okay, which need to be passed to this calculator. It is providing all these details as a JSON. Okay. This is again text generation, nothing
Mhm.
new. Okay. It is
Okay.
still text generation and we are getting all these details. So now we will parse these details and we will, since it has given us the arguments and everything, we will call that function by ourselves. So we write a Python logic to call that function and pass the arguments. And then whatever the answer we get, right? So that we will provide it back to LLM.
Mm.
So
Okay.
here the logic is being written by us. But if we look at, like, we could take a step back and look like overview. So there we can, it seems to be like LLM is using the tool, but internally we are writing all the logic to use that tool by this LLM. Okay, so we pass back the response. So now using this response and the all the generations that happened previously, the history, right? So can I
Mhm.
say this history to be memory?
Yes.
Okay, so yeah, history is saved in memory. Okay. So yeah, it has got all this reasoning and it remembers that I called this tool with these arguments and this is the response now. With that response now, it will generate me the final output. Okay. So the calculation of it will give the reasoning and then it will give the answer. Make sense?
Yep. Yep.
So that's an workflow of AI agent in a nutshell. Sorry
Mhm.
for that. Yeah, AI agent. Okay. So yeah, and the important thing is, yeah, it has got access to memory. And one more important thing is, as we can see here, so initially there was an user input. Okay, the tool, the provided tools, and there is an user input that some user input is there, and it is processing it, and then it is responding back with a JSON. Okay, where it is suggesting like which tools need to be used and what are the arguments, right? And then
Yep.
with Python function we are processing it, and then we are passing the response back to LLM, and then the LLM is responding. So can I say there is a loop involved here?
Mm. Yes. Yes.
Okay. So yeah, these could be major pillars, okay, fundamental units of making an LLM as an agent
Mm.
using this memory and loop. Okay, these are the two things which enable, which makes an LLM, a simple LLM, as an AI agent which can reason and take action. Okay. Yeah, coming
Okay.
back to this field as mentioned here, yeah, the JSON is an important format because we are providing our inputs through JSON and the response has to be formatted in JSON in order for us to process, right? If it is broken, we can't process it. We can't write in Python logic which will universally work, correct? So we
Mhm.
have to have a deterministic structure. Okay. So that JSON and then the tools, the hands, okay. So the hands are referred to like tools, available
Mm.
tools. Okay, standard Python. It could be simple as a standard Python function. Maybe executing an SQL query. Okay, we know that
Yep.
through a Python code we can execute a SQL query by providing all the details of database, how to connect to it, and what's the query to be executed. Right. So once it generates the query, we can write a function to actually execute that query. Correct.
Yep.
Calling a weather API, that's the classic Python API we all use while telling API for the first time. We'll be running a calculator as simple as that. Okay. And the loops. So this is React. So within this loop, the React is being used. So this is not a framework, but yeah, this is in like a logic, which we will discuss in the next slide. Okay. So
Mhm.
the while true loop. So this loops actually runs infinitely until an answer is generated. That's why you may have heard lately, like 2024 or 2025, right? So few of the startups, they wanted to build these AI agents to solve some problem, but
Mm-hmm.
they went into bankruptcy like too soon, right?
Yes, yes,
Because
yes.
it 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 isn't a while loop. While loop is like infinite loop, right? So this token generation is happening continuously. Let's say there is a debatable question that's been provided. So whether the chicken came first or the egg, okay? And it
Yes,
starts to debate its own reasoning. So it will
yes.
exhaust the token generation, okay, and it will create a huge bill overnight, maybe. Okay, imagine
Mm-hmm.
it's doing it on Friday night, and we visit back on Monday, right?
Yeah, yep,
So yeah, so while true loop, this is a continuous infinite loop which we will provide. It has to exit from it, so it will indicate the signals where it needs to be like exited. Okay, so with that we will be getting out of this true loop. Sorry, while loop. Okay, binds the brain and hands together, allowing continuous execution until the task is complete. Okay,
yep,
so yeah, the goal of LLM was, so what was the goal of LLM? Generation, correct?
yep.
So text generation doesn't matter if it is a fact, if it is like hallucinating, if it is biased, it doesn't care. Okay, the main functionality of LLM is to generate. It's a generation. Okay, so what
Yes,
is the main task of agent? To complete the task.
yes.
Okay, completing task would be maybe even if agent says there is no enough tool to execute this task, right? This is also
Mm-hmm.
considered to be completion of task, right? So it is explaining why it can't do it. So whether you can do it or you can't do it, it has to come to some ultimate result. Okay, so that
Mm-hmm.
is the completion of task. So the goal of agent is to complete the task, while the goal of LLM was to generate text. Okay, this
Yes,
we need to understand.
got it, got it.
So yeah, so here we will discuss on like what is this React framework anyway? Okay, which we just said, right?
Reasoning and acting, okay.
Yes,
Yeah, the
reasoning,
initially you written that logic building and
right?
yes.
So yeah, so there is a thought involved. So initially you provide, imagine there's an workflow you provide. Uh, so I have also coded an example where it is saying like let's say our application was down for 2 hours. Okay, in this 2 hours, what was the approximate like cost which we lost? Okay, ours was like shopping site like Amazon. Okay, so per hour we get around 25 orders. So 25 people provide us orders, and the average budget would be something like $45. Okay, or 4,500 is our average card or
Mm-hmm.
let's just say order value.
Yep,
So by multiplying these two, we will get like approximate loss, right? So our application was down for 2 hours. So by multiplying these two, we will get the loss, the approximate at least.
yep,
Okay. So that's the calculation we need to do now. So the user is asking, like, my application was down. Okay. My application was down by 2 hours. So yeah, these are the metrics. These are the inputs. Okay. If these inputs are already, sorry, these are the inputs 25 and 45. If these inputs are already there as a knowledge source, okay, maybe a RAG system is like involved here. And if it fetches, that's fine. If it's not there, so user has to provide this, right? So yeah, 2 hours. So average people ordering in my site is 25 and the average value is 45. Okay, what's the loss? Okay, that could be like, it seems to be a dumb question since you can
mm-hmm.
multiply those two on yourself.
Yeah,
uh, but yeah, the questions could be similar. Okay, not this exactly.
mm-hmm.
So now it will start thinking that what would be the thought. Okay, the first thing is thought. So it will think the thought it would have is, so yeah, I have been given with a problem. So the application was down for 2 hours, and the average number of people ordering per hour is 25. Okay, and the average value is $45. Okay, it's for 2 hours, so I can multiply all these three to get it. Okay, so this could be a thought, and then the thought could also be like, do I have any function? Okay, any tool
Yeah.
which can do this task to me. Okay, this could be the thought, and it will
Yep.
check through, like, then comes the action.
Mm-hmm.
Okay, so it searches for these tools. Okay, the tools are listed, so it will list out the tools, and then comes the thought. With these tools, can I answer this question? Okay, it can answer, so it will generate me an argument. And since this is tool nothing but API, right? So the arguments that need to be passed to this API and the endpoint. Okay, endpoint could be if it is a function call, right? So that is the thought. I need to do this. Okay, it will generate that, and the action would be like calling that function. Okay, so that could be an action, right? Although the action is not taken by the LLM directly. So yeah, we are providing it. So we are helping it out in order to complete this action. But yes, so it is independently doing it, right? So we have written that logic already. So now it can execute that logic. So the calling happens, the call function happens, and the response comes in. So now with the response, okay. Yeah, I missed one thing, that is observation. So here
Mm-hmm.
it observes the LLM, sorry, it observes what are the tools and then gives a thought, then takes an action. Now the response is provided from this API, the response comes in. So that's the observation. Okay. And next the thought comes in. The thought is like this is the this has been observed, and so now I can answer this question finally. Right. So now it will generate me an like text where it says, so whatever the value, 25 multiplied by 45 multiplied by 2. Okay. So whatever the value, right? So it will say this is the loss considering these things. So this is the actual loss that happened while your application was down for 2 hours. That could be my
Yep.
response.
Yep.
Since yeah, there is an LLM and you provide all these details directly, maybe it will respond back without any tools and everything. Okay. But here we have a calculator, simple calculation that's being done. So we can make it as like single LLM call. No worries. Okay, without agent. Imagine a task being done. Okay. So there are resumes which need to be passed, and these are passing to like resume agent. So here you can't magically write up a single prompt which will evaluate everything and accepts or reject a resume. Okay, there could be multiple thoughts that has to be provided depending on the job description, depending on the requirement, depending on the experience, and depending on like what would be the expectation of that particular candidate. Imagine he's out of Google and he's a great candidate, but he may not fit into startup, right? Because of the budget constraint, of course.
Yep. Yep.
Correct. So that thought has to be, that intelligence has to be involved. Okay.
Yep.
For this resume agent, yeah, it has to give a thought on it, and then it has to decide whether to accept or reject this candidate. Maybe
Yep.
shortlist him or her, right?
Yep.
So yeah, that could be actual workflow. So this could be some example workflow, which I just gave an example of. Okay. So there is involved of 3 steps. Okay. One is thought. LLM has to think for it and then take up like what action it has to, and then observe the response. Okay. So here there is only one calculator application. Imagine we passing this calculator
Mm-hmm.
application in order to get something else. There is another
Yep.
maybe function, okay, tool which needs the response from this calculator application, and then only it can process. Okay. So this is something like a simple example. A plus b
Yep.
whole square, a square plus b
Yes. Yes.
square
Yes. Two
plus
AB.
2ab, right? So
Mm.
now in order to get this, you have to calculate all this. Okay. So you need a square, you need b square. There is tool to do the squarings, and then there is tool to like multiply the things. Okay, calculator tool. So you have to get all these answers in order to calculate a plus b whole square. Correct. So it has to give thought on like whether to use a squaring function or to use a multiplication function. Correct. So depending on these observations, it will respond back with single answer. Understandable? Any doubts until this point, Saurabh?
No. 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 I'm good. I'm good.
Okay. Right. Okay. So yeah, so this is like even I had this misconception when I initially read about like agents. Okay, so So I imagined LLM to be like LLM is attached with agents. Okay, now it can tools step there. So yeah, LLM is have access to these tools, and now LLM can independently perform like imagine like this is an LLM previously which was generating agent. Now it has been embedded into like with tools. Now it can use it anyway, like however it's possible. Okay, I imagine the workflow to be like this. So this made this particular architecture to be black box. Okay, we don't know how it works, but it works. Okay, but
Yep.
the more reality is, so yeah, LLM is still the LLM which generates text. So the tool integration is like we are doing it. So it is not embedded into LLM already. Okay, both are isolated. Okay, so we are connecting these connectors using our logic, right?
Okay. Okay. Got it.
Maybe writing up a if statement. Okay, if LLM responds back with like let's say tools, and it is asking for these particular tools to be used. So I'm writing a if condition. If this tool is mentioned, okay, then I execute this particular function. Okay, else if this tool is mentioned, okay, execute. This makes sense, right? LLM responds back with whatever the tool
Yep.
it wants to use. And I'm checking it the if condition that if whether this is the tool it is asking for. If yes, I will write up a logic to execute it. If no, if something else, I will write up a logic to catch it and execute it. So LLM and tool are completely isolated. Even now it is they are not directly connected, but we are connecting it through our Python code, right? So these are not superior large language models, advanced large language models. They are the same large language models which we've been used like 3 to 4 years, right? But yeah, we have
Yep.
this separate integration that we have given. So that's the reality. So this is like misconception, which is widely considered. Okay. So the LLM is completely isolated. It just outputs the text.
Mm-hmm.
It is still outputs only the text. Okay. Your Python server interprets the JSON. It runs actual code on the CPU and pastes the result back into its memory. That is chat window. Okay. So the misconception was AI magically connecting to database and calculating the maths inside its neural network. Okay. So we thought LLM, we have provided the tools such that LLM can use them anyway. Okay. So the rules we have to decide which need to be provided and which need to be not. So yeah, that's like a simple cute masterclass on AI agents. So we will check with code now. Okay. So
Yep.
I could have used any framework. Okay, but I intentionally made a code such that so I don't have to use any frameworks, but I wanted to show you like using the raw Python, how we can convert an LLM. So you know I have Llama 3.2, right? So with this, how can I
Yep.
create agent? Okay.
Okay.
So yeah, let's just run this. Let me just execute and then I will explain the code. Okay. Yeah. Okay. So yeah, let me just explain this code now. So as you
Yes.
can see,
Yes.
I have imported only two things. That is the request to request this LLM. Okay. So yeah, it is still local, but I have to request it anyway. And I have JSON to pass this JSON output to load the JSON anyway. Okay. So that's my base URL. So usually, yeah, I have faced this problem. So if you say it to be like localhost, right? Sometimes it gives us error. It wants the exact endpoint. Okay. The exact endpoint which we have here. Okay, it is localhost here.
I think your
Completely
IP
fine.
colon
Yeah, yeah.
IP colon port rather than localhost.
Yes, that if that's provided, it seamlessly work. But yeah, it's kind of like it's been mixed up. So previously it showed me an error, but now it's not. Anyway, so we have this function now. Okay, calculate revenue loss, user dropped, and the average carrot value. Those are the two arguments. Okay, so yeah, the output is string maybe. Yeah, string of course. So here it calculates the total financial loss from a system outage. So I have try except block. Yes, we have to understand one thing. So we must never, have said this multiple times, we must never believe that our LLM follows our instruction and provides back with like exactly the data type or the format that we have asked
Mm-hmm.
for. Okay. Imagine that it's a powerful model and it respond back with JSON every time, but maybe 999 time it has responded with JSON, but thousandth the time it may not. Okay. So we always have to encapsulate this in try except block. So I have done the same. So yeah, I hope my LLM responds back with integer and float values, but I can't expect it to every time. So I have written this try except block, okay, where I'm trying to convert these are the values that LLM will be providing to me. Okay. So I'm converting these values into like integer and float items in order to multiply. Okay. Once this conversion, I'm doing a try except block because it may generate something like instead of the actual user dropped, it has to provide me with some number, right? So it may give like user drop could be something like 45. Okay, the whole statement. Now passing the whole statement here shouldn't be converted into integer, right? So it has to respond back with like exact values. That's why. So I'm converting it to integer and float. If it converted, then yeah, system calculating the loss. Okay, users, cart value, total loss. We are multiplying it, and then I'm returning the total value. Okay, so the total revenue loss. So I'm returning this whole string.
Mm-hmm. Okay.
So in the total loss, it will the calculated value will be pasted since it is in like string formatting. Okay, and this is our function. This is what it does. And then I have something called like available tool. Okay, this is a dictionary where I'm mentioning like all the tools available. So I have only one tool here. So I'm saying like calculate revenue loss. So that's the tool name. And this is an object of the tool, correct? The function name itself. I'm not encoding
Yes.
it like string. This is the function name itself, right? So if I call the value of this calculate revenue loss, I'm getting this function name now. So if I run this function name, it will execute the function directly, correct? The value here is an object, you can say. Okay, not an object, but yeah, function name.
Mm-hmm. Yep.
So then I have, sorry, I have written available tool twice. No need of this. Let me just take it down. Okay. So yeah, like writing it again doesn't make sense. And again, it doesn't bother us anyway. Okay. So this will be executed, that will be executed. So both have the same content, so nothing will change. So in the second, we have tool schema. Okay. So how this tool is. So type is, it is a function. We're suggesting that it's a function. Okay. Within function, the name of that function is calculate revenue loss. This is the information we are providing it to LLM. And the description is calculates the total financial loss from a system outage or bug. Okay. The parameters are like, it is like object properties is, these are the parameters, right? User defined and average cart value. These are the two arguments which has been taken by that function. So we're providing it. Okay. So yeah, type is integer. We are mentioning it like this is the integer type. So this has to be a number type, the description number of users affected. We are providing description for parameters and the function both, if you can observe. Correct. So required, if we are required like whatever is required. So consider there are like there is a function to add up like everything that's been sent. Okay. So the requirement would be at least one value. Okay. At most it can pass any value, right? So here we are saying that these two parameters are both required. Okay. So can I say like to use my function, if anybody watches this particular syntax, right? So they can
Mm-hmm.
use my function efficiently
Yep. Yep.
without a doubt. About function name, we know like we have described like what it does, what are the parameters, and what are the data types that has to be passed, and what's the description for those parameters, what it has to be, and the required things, right? So now with this information, we are passing it to LLM. So this is messages. So this is the memory I was speaking of. Okay. Here we have user content. So
Yep.
this is being passed, and then yeah. So here comes our agentic loop. So this is while true. So this loop will run infinitely until a break statement occurs. Correct. So while loop will run infinitely if until either the condition has to be failed since we are passing a true value here. So it will fail no time. Okay. So it is an infinite loop, but we can come out of the loop any loop using break statement in Python. Correct. So yeah, we will check on like where the break logic is implemented. So yeah, LLM thinking, that is fine. So in order to check like how many number of times this loop goes before answering our final response, right? So it is printing the loops. Okay, initially it is 1. So okay, to make it 0. And on this, yeah, in bit time I will explain. So the payload is, yeah, model is Llama 3.2. The message is, this is the memory, the tool schema I'm passing, and stream is false. If stream is true, every token is generated real time. If stream is false, we wait until like whole response is generated. Okay. So response is equal to request. We are passing our URL, the payload. Okay. Uh, and once the response comes in, we're expected to be JSON format. The response is JSON now. So we are extracting message out of that JSON, and we are appending it to like memory. Okay, whatever the response comes in, we are appending it to our memory. That is messages. And then if there is a tool call, okay, we are checking if the tool call, if that call, whatever the tool mentioned with the LLM response, right? If that exists in our toolbox, okay, we have certain that tool. Okay, it may hallucinate, correct? So we are checking if it exists in our toolbox, and if yes, we are checking on the function name, and we are extracting particular arguments that need to be passed. Okay. Here, if I could print this, that would be great. Let me check if I could print this. Print message. I'll print the whole thing maybe, or only the message.
You can print whole thing.
It will be repetitive. The whole
Okay, okay.
first user request. Okay, so that's why. So I'll print the message content. Okay. So yeah, we are checking with if that function exists and the arguments are correct. Okay, and then we are executing that particular function. So this is a print statement that you can ignore it. So here you can see available tools of function name. So what it gets within the available tools, the function name. Could see that is the value is the function itself, right? Right. Oh yeah. So available tools, that's the dictionary, and within the dictionary, the key we are passing is function name. So that is the function, actual function name itself is the value, right? So we'll get actual function name. So we are passing it as like function to call. We are passing it to this variable, and then the arguments we are passing it to. Then we are actually calling that function. If you could see function to call, right? So we are passing that. We're actually calling that function with the arguments that's being extracted. Now, whatever the results are, we are getting this result. I'll just print this result maybe, or I can print the message again. Okay, I can print the tools, no worries. So print, sorry. Okay, now I've added a print statement. Now that everything will be appended and it will be passed back. Yeah, here there is continue, right? So since there is continue, the loop reverse back, and now with all the updated messages, now it will again check through. So from the here, so it will check again. Okay, so now it has got a result. Now it will check on like what to generate. So now there is an if condition that whether it wants to call the tool. If not, the else statement will run, and within the else statement there lies a break statement. Once this else statement is run, the agent will stop this loop and comes out. The execution stop this loop and it comes out, right? So let's just run this. So LLM is thinking for the first time the loop was running. The loop is running. So the messages only contains the user input now. So you can see LLM decision needs to use a tool calculate revenue loss. Okay, LLM extracted arguments. User dropped is 150. So you can see this is string still. Average start value, this is again string because it can only generate string now, our model at least. Okay,
Yep, yep.
system executing code, calculate revenue. So this is the function call that's happening with these two arguments. Okay, system executed tool, calculate revenue with the results. Yeah, this is the response. Understandable? 6825 is
Okay.
the multiplication.
Yeah, it calculated everything. Yep.
Yes, pass the result. The total revenue loss was back to the LLM. So we are passing it to LLM. This is print statement. Okay? This is not LLM generated. But yeah, values are like we are formatting it. So LLM is thinking. So the second loop comes in. Calculation is being passed now, already passed in memory. So this means that if 150 users were unable to unable to complete their checkout due to UI bug, the each user had an average cart of like 45, then the total financial loss would be something like 6825. So this was extracted by the calculated by the calculator application. Okay. So here comes the agent's final response. So here we are printing the messages, right? So that's why this thing is printing is being printed out, or else this won't be visible to user. Okay, this whole thing is like we are printing it because
Yeah.
we are developers, but for us
Yes,
of
yes, yes.
users, so this is the only thing that's visible. This means that if 150 users were unable to, okay, all the description and that particular answer. So it took almost 15.6 seconds in order to get this response. Correct?
Yep, yep.
So yeah, so we created an AI agent using only the raw Python which we know. Okay. So by this, can we prove the LLM needs only the loop and the memory to convert it into like an agent? Okay, it's
Hmm.
like evolving a Pokemon from stage one to stage two,
Yes, yes, yes.
right? Yep. So this is the thing. So we have to go through how AI agent works and how agentic AI system works. So in order to better know how agentic AI works, right? So you have to understand the nodes within it. So agentic AI is nothing but the set of agents that are working, right? So I wanted to show you guys like how exactly an AI agent and like what exactly is an AI agent. Okay, to make the fundamentals better.
Hmm.
Hope that worked. I will pass down this particular function. No worries.
Okay.
So maybe you can add up your own tools, okay, your own functions, and then add up those into tool schema and pass it to LLM and ask it like different queries for it to choose between the tools. Okay. Imagine I have
Yep.
like 10 tools, and every time the query comes in, it has to decide which tools it needs to use. Okay. That
Yep.
reasoning depends on the reasoning ability of that particular model. Okay.
Hmm.
So yeah, you can play around with this code and let me know if something goes wrong or something like that. Okay. Any doubts until this
Yep.
point?
No, no, no. I'm good. Good.
Or you want me to try something in this particular function? Sorry, code.
What I understood is LLM is just creating the strings, like the words, the one which can
Yes.
interact with the user. But the actual logic is the tool,
Yes.
and LLM with the tool combined is called agent so far.
Exactly.
Okay, okay, okay. Tool can
Yeah.
be anything.
So yes, tool can be any function or API call. It may be external API call.
Hmm.
Imagine, so I have this application in my company where it calculates things based on like whether that document is fetched, depending on the contracts. Okay.
Hmm.
So every time it has to use a separate external API to get that contract. Okay. So it could be external API calls or internal API calls, or it could be function, as simple as that could be. Okay. So yeah,
Yes.
always imagine LLM to be agent is not like the tools embedded in LLM. Okay. So it is
Hmm.
tools that are connected to LLM via our code.
Is the agent.
Yes. So that's the like subtle difference which makes the
Hmm.
change in
Hmm.
regular people speaking of agents and the one who understands the agents.
Yes.
Okay. Sure. That's what I wanted to present today. So maybe tomorrow
Yep.
we will speak on like orchestration of these agents. Okay. So maybe
Yep.
agentic AI. What do you call?
Orchestration as in like the higher